Alright, boys and girls, ladies and gents, this is lecture number 5. We are going to this is probably the hardest, I think maybe in dealing with complex numbers, is dividing a complex number with another complex number, or by a complex number. But before we do so, we have to learn a new term. It's called conjugate. The conjugates of complex numbers kind of works pretty easy. Let's take, for instance, you have a complex number in the form of a plus bi. Alright? All we have to do is to find the conjugate of that number is flip the sign, change the sign that's in front of the imaginary portion of your complex number, which is right here. And that's why instead of writing a plus bi, the conjugate is a minus bi. Okay? Now, it works the same way if we have a number that's in a minus bi form. Okay, the conjugate of that would be this. Okay, all we did was change the two signs in front of the imaginary portion of the complex number. Okay, now the reason why we're talking about conjugates is that when we have an example such as this, that's going to help us simplify and solve and divide these complex numbers. If we went back from the previous lecture, we don't want I on the bottom. We don't want I in the denominator. Now, since this is a complex number here, okay, I have to deal with it a little bit different than what I did in the previous lecture. Okay, so here's what we're going to do. We're just going to cut to the chase here. I'm going to multiply, but I'm going to put parentheses around this. This guy, I'm going to conjugate it. So in other words, I'm going to multiply the bottom by 4 plus 3i. And just like in the equation, I'm going to be fair and do the top. 4 plus 3i. Alright? Now, just like fractions, we got to multiply straight across. Now, here's the thing. That's a lot of fooling. Okay? But watch what happens when we fix the bottom first. Okay? So this is what you need to see first and foremost. If I multiply the 4 minus 3i and the 4 plus 3i, okay, here's the cool thing that happens. 4 times 4 is 16. 4 times 3i is positive 12i. Alright, right here, pay attention. I got negative 3i times 4. Well, that is minus 12i. And then right here I have negative 9i squared. Okay? Now, the two middle terms here. Guess what happens? They disappear. Because when you combine like terms, you got to combine all your real numbers together. And you want to combine your imaginary numbers with imaginary numbers. Well, my imaginary numbers disappeared. 12i minus 12i, it's gone. It's erased. So we bring down this, and I know what I squared is negative 1. So now I got 16. Distribute that, that's plus 9. That gives me 25. So I'm going to put 25 on the bottom. I have a real number. That's what conjugates do. They get rid of the imaginary part and they produce real numbers. Now, is that the case on the top? No. Alright, and I'm going to write in a different color here. So I got to multiply the top now. 3 plus 2i, and then 4 plus 3i. Okay, you multiply by conjugates, just like we did here. 3 times 4 is 12. 3 times positive 3i is 9i. Multiply the middle part together. 2i times 4 is 8i. And then last, we have positive 2i plus times positive 3 is 6i squared. Okay? Combine your middle terms here. Those are the imaginary portion. It's going to give me 17i. Bring everything else down. What can I go ahead and plug in for I squared? -1. So 12 plus 17i. Distribute, that's -6. Combine the real numbers together. 12 minus 6 is 6 plus 17i. Okay, that's what I got for the top part. So I'm going to write that up here. Alright. Now, there's no real reduction in this problem. We may run into that tomorrow in class on the DMP. If we do that, we'll address it in class. I don't want to waste any more of your time. So I will see you tomorrow. Later.